so y'all go ahead and do the factoring to the math knowledge question, pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you're going to want to factor out your greatest common factor, which on this one is a 2x. So if I factor out a 2x, I'm going to have x squared plus 20x plus 100. And then that'll factor as x plus 10 times x plus 10, which you can write as 2x times x plus 10 squared. Okay. For the math knowledge question, the circumference of each tire on his bicycle is 50 inches. About how many revolutions does one of the bicycle tires make traveling 300 feet, which they tell you as is 3,600 inches. It says without slipping. So we want to travel 3,600 inches, and one rotation of our tire is 50 inches. So basically you're just going to divide 3,600 divided by 50, and you're going to get 72 revolutions. So you would have to make 72 revolutions to go about 300 feet. So we are looking at lesson 84 today. We're looking at factorable expressions, and then we're going to look at sketching sinusoids. Okay? So hopefully you'll understand how to factor some of these expressions that they give us, and then we're going to look at the sketching of sinusoids. So I want you to go ahead and write all of these down. Y'all can pause the video and write them all down, and then we're going to practice factoring these. So x cubed would factor as sine of x times sine squared. And then we could possibly rewrite that sine squared is 1 minus cosine squared. And we could factor 1 minus cosine squared if we wanted. But that could be how you could simplify or rewrite sine cubed. For tangent squared theta minus 1, that's like an x squared minus 1. And it's going to factor as tangent of theta minus 1 times tangent of theta plus 1. So that would be how that would factor. For 1 minus tangent of theta, it's going to be almost identical. It's going to be 1 minus tangent of theta and then 1 plus tangent of theta. For this next one, you would say cosecant theta minus 1 and then cosecant theta plus 1. Okay, so those three are all kind of related. Now for this next one, sine x minus sine x cosine squared x, that's going to have a sine in both of those, so we can pull out a sine of x, and then we're going to have 1 minus cosine squared, which you can again factor 1 minus cosine squared as 1 minus cosine of x times 1 plus cosine of x. So if you wanted to write it like that, you could. This is the same thing as sine cubed of x, but they don't at all look the same because they both factor as sine of x times 1 minus cosine squared. So that's one way that you could factor that one. For the next one, it's to the fourth. Well, x to the fourth minus y to the fourth, it would be x squared minus y squared, and then x squared plus y squared. But then this x squared minus y squared would factor as x minus y times x plus y, and then x squared plus y squared. And so that's basically what we're going to do to this one. We're going to make it the cosecant squared of p minus cotangent squared of p times cosecant squared of p plus cotangent squared of p. But then this one would factor further as cosecant p minus cotangent p times cosecant p plus cotangent of p, and then cosecant squared p plus cotangent squared of p. So that would be how that would factor. For this next one, it's basically, I'm going to put it in a different order, but x to the fourth minus 2x squared minus 1, which would factor as x squared minus 1, and then x squared minus 1, which both of those will factor further. So you would have, I'll write it in a different color. Sine squared minus 1 times sine squared minus 1. And both of those would factor as sine of x minus 1 times sine of x plus 1. And we can just square them because we've got 2 of them. Okay? Now looking at this last one, sine cubed minus cosine cubed. Well, we're basically just going to apply our difference of two cubes formula. So I would have the sine of x minus the cosine of x, and then times sine squared x plus the sine of x times the cosine of x plus cosine squared of x. So that's how that one would factor. Okay? So we're going to use those concepts in these show that's. We want to show that sine of x minus sine x cosine squared of x equals sine cubed of x. So on this one, we're going to start with the left side. So we start by writing it down. So we have sine of x minus sine of x cosine squared of x. I can factor out the sine of x, and I have 1 minus cosine squared of x left. 1 minus cosine squared is the same thing as sine squared. And so sine of x times sine squared is sine cubed, which is what they gave us. And so this would be your answer. Let's look at another one. We want to show that these equal each other. So we're going to start with the right side, the left side. We want to show that it equals the right side. So write down your left side. So the left side, we want to factor the numerator here. Secant to the fourth x minus tangent to the fourth is going to be secant squared x minus tangent squared x times secant squared x plus tangent squared x all over secant squared x plus tangent squared x. And we have plus tangent squared x. So the secant squared x plus tangent squared x will cancel, and I just have secant squared x minus tangent squared x plus tangent squared. And now negative tangent squared x plus tangent squared x goes away, and I'm just left with secant squared x, which is what they gave us. So all of this would be your answer. Okay, so that's how you would use factoring to help you with that show that. Let's look at one more. We want to work with the left side. So we have cosecant squared x minus 1 over tangent of x. Now factoring isn't going to help you on this one. What we're going to want to use instead is our Pythagorean identities. And so hopefully you'll remember those. The first one that we dealt with was sine squared plus cosine squared equals 1. We have a cosecant. So if you don't remember the Pythagorean identity that had cosecant, cosecant is the reciprocal of sine. So we're going to want to divide by sine squared. Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. And then we have equals cosecant squared. Now we have cosecant squared minus 1. So if I subtract 1, I get cotangent squared equals cosecant squared x minus 1. So that means that the numerator is actually the same thing as cotangent squared x. And then I have over tangent of x. Well, instead of dividing by tangent, I can multiply by cotangent. So cotangent squared times cotangent is cotangent cubed, which is what they gave us. And so this would be your answer. Okay, so that's looking at factorable trig expressions. Now we're going to move on to sketching sinusoids. So the first thing that you're going to want to do is to start by sketching your little sinusoid. And every time you're always going to have your humps. You're not going to fill in any numbers until after you already have all the humps drawn out. Okay, so go ahead and draw that. I like to, on my line paper, I've got my lines. I like to go like this to help me keep it straight. and it'll give me enough room to fill in all of my information. You don't want to make it a little bitty sinusoid because then you're not going to be able to fill in all of your numbers that you need to, okay? So the first thing that we're going to do is start by writing Calc. That's our friend that helps us figure out sinusoids. Okay? So the C is for our center line. Our center line here is -10. The 2 is our amplitude. So we go up 2, that gets us to a -8, and we go down 2. That gets us to a -12. Now we're going to have a sine function, because that's what they tell us, sine, and our angle is a positive 45 degrees, because remember, whatever that angle is there, it's the opposite of that. So instead of going to the origin at 0 degrees like this, don't draw this line, I'm just going to show you. Instead of doing this, that angle here is going to be a 45-degree angle. Instead of it being your y-axis, that is your 45-degree angle. Now we have to deal with that 3. What that 3 means, we take 360 and divide it by 3, and we get 120. That means that going from this point over to this point is 120 degrees. So 145 plus 120 is 165. And so that means that our period is 120 degrees. And now all we need to do is fill in these points here, okay? We don't have to use the rest of this curve over here, so if you want to erase all of that, you can. Or you can just not fill in the numbers for it. Now, if going from the 45 to the 165 was 120, adding from one to another is going to be 30 degrees, because each of these is a fourth. So this is going to be 75, and then 105, and then 135. And then if you add 30 again, you get to 165. And then we're going to subtract by 30. So we'll have 15, subtract another 30, you'll have -15, subtract another 30, and you're going to have -45 degrees, okay? Now the last thing that you need to do is to place your y-axis, and so it's halfway in between the -15 and the 15, and so I'm going to put it halfway in between there, and that's my y-axis, and this is my x-axis. Okay, so that would be what you would need to put on your sinusoid. You do have to put all of these numbers, and they do all have to be correct. So you'll see on your answer sheet where I wrote them in because the book didn't give all of them, but I want you to practice doing that so that you understand where they're coming from. Okay, so hopefully that makes a little bit of sense. Y'all may need to pause the video and go back and re-listen to something, or maybe talk amongst yourselves to try and figure it out, and that's fine if y'all need to. Okay, so now let's look at this one. We want to sketch the graph, and this is a cosine. We start by saying Calc, because that's the person that helps us with these, Calc. So our center line is -2, and then we go up 4 to 2 and down 4 to -6. And it's a cosine. So normally we're going to hit a peak, a max, at a cosine. But instead of it being the y-axis, it's this angle that is going to be -2 pi over 3. I'm actually going to move it back one and put it here. -2 pi over 3, because it's always the opposite of that angle. And so that's where my max is going to be. Now on this one, it is in radians. So instead of using 360, we're going to use 2 pi. And we're going to divide it by 2 because that's the coefficient that they gave us. And we get a pi. So that means that going from this -2 pi over 3 to this here is pi. So -2 pi over 3 plus pi is 1/3 pi. Okay? So now what we need to do is fill in some more information. Each of these is a fourth of pi. So if we take -2/3 pi and we add 1/4, well, what is 2/3 plus 1/4? They both have a common denominator of 12. and this would be a -8, and this would be a 3. So we're going to have -5/12 pi. And then we're going to add a fourth again, which is 3/12 pi. And we're going to get -2/12 pi, which is -pi/6. And then -2/12 pi plus 3/12 pi would be 1/12 pi. And if you added a fourth of a pi, which is 3/12 pi, you would get 4/12 pi, which is your pi/3 right here. Okay, and now we need to go just a little bit further. Let's get all the way to here. So if we added to 4/12 pi, we add another 3/12 pi, we get 7/12 pi. So this number is 7 pi/12. And then we need to add one more set of 3/12 pi, which is going to be 10 pi/12, which is 5 pi/6. And so that's probably enough right there. But that is almost everything we need to do. Now we just need to add our y-axis. And so we have a -pi/6 here, and then a positive pi/12. So it's going to be a little bit closer to the pi/12. And so that would be our y-axis, and that would be our x-axis. So on these, you need to have around 8, I would say, marked on your x-axis, 8 different angles marked around that, 7, 8, 9, somewhere in there. But that's how you sketch your sinusoids. Most people are able to get the center line and the amplitude correct without much trouble. The part that takes the practice is the angles. So again, if you want to go back and re-watch the videos, you can. They are online, so you can look them up at home as well. But hopefully that helps you with sketching your sinusoids. As far as your homework, 1 through 30 is due tomorrow, so make sure you do that tonight so we can go over any questions you have tomorrow.